Whoa! Whoa, 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 whoa. I'm gonna polar graph today, and I'm gonna see what I can do with it. Let's go. Let's begin with r equals sine theta. Well, what this graph does is convert the Cartesian coordinates into polar coordinates. So instead of x comma y, it's r comma theta. No, it's theta comma r, or r comma theta, depending. Well, r is a function of theta. R equals f of theta, and as y equals f of x. R squared is equal to x squared plus y squared. That's what you use to convert the Cartesian coordinates into one of the polar coordinates. Y equals r sine theta, and x is equal to r cosine theta. We can use that to convert any Cartesian graph into a polar graph. So this is sine theta, r equals sine theta. So basically this is y equals sine x, but it's converted to polar coordinates instead of Cartesian. Let's do this. We have kind of like a flower. What about sine 2 theta, cos 2 theta? We have double the petals, right? A flower with double the petals? It's good. It's good. What I'm using is desmos polar graphing. So let's do sine 2 theta minus cosine 4 theta. We have an interference pattern. This looks kind of like an electron cloud in physics. I don't know if I'm relating to any of you, but this kind of looks like an electron cloud. If we do the negative and then plus, so sine 2 theta minus cos 4 theta equals r. It's the same thing in polar coordinates. So to convert Cartesian coordinates to polar, r equals square root of x squared plus y squared. That is to convert a polar to a Cartesian and vice versa. What's happening? Whoa, whoa, whoa. Let us do a Fourier series with polar graphing. Bro, what's happening? Okay. I keep clicking the triangle accidentally. So, r equals, can we do sums? Sum n equals 0 to 50. Sine, instead of x is theta, 2n plus 1 divided by 2n plus 1. So this is the square function, but converted into polar coordinates. So a Fourier series converted into polar. It looks like a half circle, basically. Cosine theta times 2n got 2 and plus 1. And now we have a graph that's like this. This is some Fourier series, but it's polar. So let's do from n equals 2 to 50 of x, no, not x, theta times 2 and minus 1 divided by 2. Looks like a bow and arrow. Looks like a bow and arrow. Sadly, you cannot hear the sound. R equals. Now we're gonna do sine theta equals cos r squared. No? Okay. Cos r equals r. No, not t. Sine theta minus cos theta square theta. So, by the way, y equals r sine theta, x equals r cos theta. That was the polar function for polar. And for phi, for 3 dimensions, z equals r cos of phi. Phi is an angle in the 3rd dimension, a 3-dimensional angle. So phi is another angle, but it's in a different axis. So theta and phi are very similar. And it's like that. So these are the polars. And for 3 dimensions, r equals square root x squared plus y squared plus z squared. So it's like that. One last graph. It's an ellipse. And if we do theta minus anything, it rotates. And if you rotate it 3 pi times, then if you put minus 3 pi, it's the exact same thing. Like that. Any multiple of 3 pi. Any multiple of 3 times pi.